And for today's lesson, we will be working with these two standards. I can write and evaluate numerical expressions involving whole number exponents, and I can perform arithmetic operations, including those involving whole number exponents, in the conventional order when there are no parentheses to specify a particular order. So today we're going to start by squaring a number. And squaring a number gets its name from finding the area of a square. So one of the properties of a square is that all of the sides are congruent. So if you were going to find the area of a square, you would take length times width. Well, its length would be 8, and its width would be 8. So we're taking a number and multiplying it by itself. And that is how we get the term squaring a number. And we can shorten our multiplication sentence by using something known as exponential form. And exponential form requires the use of a base. So in this case, our base would be 8 because that is the number that we're multiplying by itself. And since we have 2 8s, we are going to use our exponent of 2. And so when we see this, we do call it 8 squared. And 8 squared just means 8 times 8. And 8 times 8 is 64. So if we're squaring 8, we do get the result of 64. So if the question says to find the square of 5, we can think about this as being a square, and we're taking the area of a square. So we would take 5 times 5, which you could think of as 5 to the second power, or 5 squared, and 5 times 5 is 25. Just a couple pieces of extra information here. The square of a whole number is called a perfect square. So since 64 is equal to 8 times 8, 64 would be the perfect square. 5 is the square root of 25 because that's what you multiply by itself to get 25. So the square root of 25 is 5. And we do, when we see 8 with the exponent of 2, we do read that as 8 squared, or we could also say 8 to the second or 8 to the second power. So if we want to square each number, if we're going to square 6, that just means we take 6 times 6, which is 36. If we're squaring 7, that just means we take 7 times 7, which is 49. If we're squaring 9, we take 9 times 9, which is 81. If we square 11, that means we take 11 times 11. And if you have to do your multiplication in our standard form, that's perfectly fine. For a lot of them, you will, especially if they're 2-digit numbers, and we would get 121. If we square 14, we just take 14 times 14. And we do get 196. And then if we're squaring 25, just like we did with everything else, we just take 25 times itself, do our multiplication, and we would get 625. So now we're going to add a dimension, and we're going to go from squares to cubes. And we know that cubes are constructed of squares, which means, once again, all of the dimensions are congruent. So if we're finding the volume of a cube, we take length times width times height. Well, if it's a cube, the length, the width, and the height are all going to be the same. They're all congruent. So we could write this in exponential form. Our base is 4, and our exponent would be 3 because there are 3 4s that we're using. And so we would take 4 times 4, which is 16, and then 16 times 4 is 64. So if we're going to cube 7, we just kind of think of that as being finding the volume of the cube. So we take 7 times 7 times 7. We know that 7 times 7 is 49. So when we take 49 times 7, 9 times 7 is 63. 7 times 4 is 28, and 28 plus 6 is 34. So 7 cubed is 343. So just like we have perfect squares, we do have perfect cubes. So the cube of a whole number is called a perfect cube. Since 64 is 4 times 4 times 4, 64 would be the perfect cube. We do read 4 to the third power as 4 cubed, or you could say 4 to the third or 4 to the third power. And then 7 would be the cube root of 343. So just that little bit of extra information there for you. So if we cube each number, that just means we take the number and multiply it by itself 3 times. So 5 times 5 is 25. 25 times 5 is 125. So we take 6 times 6 times 6. 6 times 6 is 36. 36 times 6 is 216. To cube 8, take 8 times 8 times 8. 8 times 8 is 64. 64 times 8 is 512. Cube 9, take 9 times 9 times 9. 9 times 9 is 81. 81 times 9 is 729. Scroll this down a little bit so I can do my work for cubing 13 and 16. So to cube 13, start with 13 times 13. And when we take 13 times 13, you do get 169. And then you have to take 169 times 13. 9 times 3 is 27. 18 plus 2 is 20. 3 times 1 is 3 plus 2 is 5. Start the next line with a 0. 1 times 9 is 9. 1 times 6 is 6. 1 times 1 is 1. Add those together. 7, 9, 11, 1. You get 2,197. And then to cube 16, it's the same process. Start by taking 16 times 16. Add those together. We get 256, and then take 256 times 16. We get 36. 30 plus 3 is 33. 12 plus 3 is 15. 2, add those together. 6, 9, 10, 4. You get 4,096. So if you're squaring a number, you multiply it by itself. If you're cubing a number, multiply it by itself 3 times. And then finally today, we're going to do some work with the order of operations. We're going to include exponents now. So as always, we follow our order. We do parentheses, then exponents, multiply and divide from left to right. And that's what's important to remember. We multiply and divide left to right. Excuse me. And then add or subtract from left to right as well. So if we want to find the value of 3 squared plus 4 squared, we don't have any parentheses, but we do have exponents. 3 squared is 9. Then we do 4 squared, which is 16. And 9 plus 16 is 25. So with exponents, we also work left to right. So 7 squared, that's 49. 2 squared is 4. And 3 cubed is 27 because it's 3 times 3, which is 9, and then 9 times 3, which is 27. So then we do 49 times 4. 4 times 9 is 36. 4 times 4 is 16. Plus 3 is 19. So 196 plus 27 is 223. 10 cubed is 1,000 because it's 10 times 10 times 10. 4 squared is 16. 5 squared is 25. We need to make sure that we're multiplying before we subtract. Remember, multiplication division comes before addition or subtraction. 16 times 25 is 400. 1,000 minus 400 is 600. 5 squared is 25. 5 cubed is 125. So 25 plus 125 is 150. 6 cubed, we can look back in our notes and find that that's 216. 4 squared is 16. So 216 plus 16 is 232. 7 cubed is 343. We can look back in our notes to find that. We can also look back in our notes to find 4 cubed, which is 64. And we take 343 minus 64. Well, we can't do 3 minus 4, so I need to do some borrowing. 13 minus 4 is 9, and 33 minus 6 is 27. So we get 279. And then our final examples. 3 squared is 9. And you'll notice once again that I'm doing one step at a time, underlining what I'm doing. So 5 cubed is 125. And this way I don't get confused and I'm just going very methodically through my steps. 9 squared is 81. So I'm going to take 9 times 125. 9 times 5 is 45. 9 times 2 is 18. Plus 4 is 22. 9 times 1 is 9. Plus 2 is 11. So I have 1,125 plus 81, which is 1,206. 8 cubed is 512. 4 squared is 16. 5 squared is 25. And again, if needed for problems, if you have to do that work off to the side, for example, you may not be able to do 512 divided by 16 mentally, and that's perfectly fine. That's a tough one for anyone to do mentally. So 16 goes into 51 3 times. 3 times 16 is 48. 51 minus 48 is 3. Bring down the 2. 16 goes into 32 twice. 16 times 2 is 32. 32 minus 32 is 0. So 512 divided by 16 is 32. And then 32 minus 25 is 7. Oops, went a little too far there. Here we go. 7 squared is 49. 6 cubed is 216. 2 cubed is 8. So remember, we divide before we would add. So I'm going to do my division off to the side again. 8 goes into 21 2 times. 2 times 8 is 16. 21 minus 16 is 5. Bring down the 6. 8 goes into 56 7 times. So we'd have 49 plus 27, which is 76. And then our final example for today, 9 cubed, we can look back, that's 729. 4 squared is 16. 3 cubed is 27. So again, we have to do our multiplication before we subtract. So I'm going to take 27 times 16. We get 432. 9 minus 2 is 7. 12 minus 3 is 9. And 6 minus 4 is 2. You get 297. So that is our lesson for today, and I hope this video helps.